Hello and welcome to our keynote speech. Today we have Joe Grand coming up for you. Joe is an OG hacker. Joe is a hacker's hacker, where an engineer might ask, how can I make this work? Joe asks, what happens when I poke here? But he's not just a reverse engineer and a creator of tools. He's also the person who was behind the first 5 series of DEF CON electronic badges to which we kind of trace our badge life heritage. So in that sense, father of badge life. And that's why I think it's super fitting that he's coming on today to give us a talk about the process behind making what is certainly the biggest badge he's ever made. It's definitely the biggest badge I've ever seen, probably the thickest badge ever as well. So please join me in welcoming to the Hackaday Supercon stage, Joe Grand.
Thank you. Will C. told me to walk on stage like that. Let me turn this off. Okay. Now that everybody's awkward and uncomfortable, hello. My name is Joe Grand, and we're going to talk about the world's thinnest boombox. Let's see. Thank you for the introduction. Thank you for everybody being here. I've always wanted to come to Supercon, and this was a great excuse. And finally, I have something I feel worthy enough to share with people. And it's also really exciting to see so many friends again in person. So yeah, this is really, really cool. So thanks again. Yeah, so this talk really is kind of about the process of this particular project. And I haven't actually worked on like an engineering project in a long time. So I thought, why not? This whole thing started with these super thin piezo electric speakers, which I had always thought like, the piezo buzzers and stuff, right? You drive it at 4K and it's really annoying and it just beeps. I didn't know that you could actually make more sound with it. So this is something where TDK had contacted me, yes, like the cassette tape manufacturer back in the day, and now components. And they're like, can you build a project with some of our stuff? So I started browsing through their catalog and saw these, and I was like, oh my God, this is awesome. Got to do something with it, right? It's like you find something cool, and then you want to turn it into something. So these are really thin, and they're like a stack of 9 layers of magic. And then they actually will vibrate, right? So like even with piezo elements, I never even thought about how they actually operate, but their voltage is causing some distortion or flexing in something, and that's against something else that's causing sound. So this is kind of cool, just sort of showing that. And of course, the natural idea was like, well, if this thing can make sound, we have to make a boombox, right? What better thing to make? And honestly, like I've never owned a boombox, but I've always loved music. And I remember as a kid listening to Grandmaster Flash and the Furious Five and their boombox. And my friend down the street had a boombox, so we would like walk around the neighborhood with it. And everybody thought we were a little bit nuts. But the boomboxes in the 70s and 80s was a kind of cultural revolution. It's almost like, I was thinking about this last night, it's kind of like Badge of Life, where, everybody is building kind of custom things to show off their own kind of design styles or uniqueness or whatever. Boomboxes were the same way. There's all these different ones, and it came down to like street cred of how big the boombox could be and how loud and what features, and you're kind of spreading your message and making a statement. And I've just always gravitated towards that. And then from an engineering side, just the design perspective of them. Like they just look awesome. So yeah, there was also this JVC, also called the king of the boomboxes, the RC-M90. This is something that was on LL Cool J's radio album, if you remember that, from '85. The Beastie Boys had it. in an early photo. I think this photo was 84. And, you know, basically across like hip hop and rock and punk really going on in New York City. So it kind of spread across this phenomenon of boomboxes. And it really was a way for people to kind of spread their message, which I really liked. This was Radio Raheem from Do the Right Thing. Again, an epic movie worth watching and again, making a statement, right? So these things really have kind of their place in history. And not my collection, but somebody's collection in New Zealand, a guy named Craig Kenton, which I think he was trying to sell all of these a little while ago, but it's just really cool. All the artistic elements of it really were nice. So when I decided to create this, I had to start with something, right? And of course, like the first thing I did is say, okay, are there any kind of reference designs, anything I can start with? And as a hardware person, I'm like, how the heck am I even gonna get a music player that plays music and then does all this other stuff? Like I actually didn't really know where to start. But I ended up finding this thing called the Pirate Audio module from Pi Moroni, who it turns out makes a lot of Raspberry Pi kind of modules and accessories. So I could actually use those as building blocks as I started building up this system, which is kind of cool. So this basically was Raspberry Pi Zero with their module, which has their display, some physical buttons to choose the tracks, and a line out. So kind of a good, you know, basic little music player. And I'll talk about the software a little bit later on. So started with that and then moved on to kind of my proof of concept. So this way I could, you know, test everything before I actually make a board, which I'm glad I did because it ends up, the boards were quite expensive to make. So, you know, doing these step by step ended up being better. So here's kind of like what I did when I started with the Raspberry Pi in the center and then little by little built up each module one by one until I could make sure everything worked. So Raspberry Pi 02W in the middle, got my battery. This is something I just found on Amazon, less than a 1/4 inch thick. So this is actually like the thickest thing in the whole boombox. So I blame battery technology. Once that's better, we can have even thinner boomboxes. But this is actually a 5 amp hour. And it's, I think, I don't remember the specs, like 1.5 amps or something. So like it will last, you know, a dance party or a street party or block party or whatever. So I'm basically feeding that into some on-off circuitry. Pi Moroni, again, had a module that they called like the on-off shim, so you could properly shut down the Raspberry Pi in a way that you're just not gonna like bork the file system. And that's like some MOSFETs and basically like sending a GPIO input, so sending a line to the Raspberry Pi, asking it to shut down properly, and then it shuts down, and the Raspberry Pi sets a pin high, and it will turn off some MOSFETs. So that was really nice, because normally you don't have that functionality, right? And with the Raspberry Pi, you have to be really careful. You don't want to turn on your boombox and like have to, you know, reset up the file system, and then you can't play your music, or you totally break it. So for the VU meter side of things, because every boombox needs to have some action on the front side, of course, using NeoPixels, and Adafruit actually has the SK6812-E, which is the reverse-mounted version. So they're not the big ones that are shown here, but they're like slightly smaller. So I took a bunch of those, and I think I can't even remember, there's like a lot on each side. 12, I think, on each side, and we'll see that later on. And for that, Adafruit actually had some libraries. Again, we'll talk about the software. There's kind of like a bunch of mashing of software together, as typically happens, which magically it seemed to all work. So yeah, NeoPixels. For the audio side, used a digital analog converter. This is a TI PCM 5100A. So I2S digital, you know, coming from the Pi, analog here, and then that goes over to an LM48580. And that's the piezo audio amplifier. So kind of a regular audio amplifier taking in line in, but specifically designed to drive piezo element speakers, which is cool. And you could actually still get them as opposed to like most other types of components. So I ended up getting a little development board for that so I could test everything out. But yeah, you can get the chips still, like they're available. So you can actually maybe do something more with these types of things. So yeah, audio amplifier then drives the piezo speaker elements, and I just have one here that I'd like taped down with some special double-sided tape. It's like a Tessa tape that's kind of flexible, so you can stick stuff down, but then if the element breaks, because they're really fragile, you can like peel the tape and it kind of comes off, which is neat. And what else do I have? Oh yeah, you need a way to control it. So I'm using some capacitive touch. It's a microchip CAP 1166, which is already used in a lot of Raspberry Pi projects. So again, another Primeroni module that I could use for testing. They already had their library set up to work with capacitive touch. And then it was a matter of kind of integrating everything together. Once I proved that all of this worked, I could then move on to developing the first board, which is the prototype board. And another reason why this ended up being really helpful is right before I was about to order the prototype, once in a while when I would turn this thing on, the VU meter would work. Like it looked like it was playing music, but it actually like wasn't. So I traced everything back, and like audio was properly being decoded and sent to the amp and everything. But it turns out that the amplifier, there's a shutdown pin that the datasheet says, pull the shutdown pin high to always enable the, it's active low. So pull it high to always enable the device. And I think for some reason, the way the power supply was getting set up or settling or something, like sometimes the audio wouldn't actually come out of it. And I'm like, well, that's not gonna be good. So it turns out that, I don't know if it was like a timing issue or something. So I basically set the shutdown pin to be controlled by a GPIO pin of the Raspberry Pi. So once the Pi properly booted, then it would enable the audio amplifier. And that seemed to work a lot better. And now the Boombox at least like turns on and plays music. And I'm really glad that happened then and not like as I moved on to the next steps. This is the prototype board. And I wanted it big enough so I could verify that like the LEDs are gonna work the right way and everything, but I didn't want it too big because it was gonna cost way too much to make. The LM48580s, the piezo speaker drivers are 2 millimeter or 3 millimeter by 1.6, they're small. Really small, like micro BGA, I think 12 ball micro BGA, which nobody ever wants to have to deal with. But that was the only package that it came in, right? So it's like little by little, we're getting forced into using BGA, even if we don't want to. And those required laser drilled micro vias in pad to go from layer 1 to layer 2 to break out some of the inner connections. So that was just a design requirement that I had to do that, which ended up, making this board go from X dollars to X squared dollars. Yes, says the circuit board fabricator over there. So I did it for the DEF CON 27 badge, also grudgingly because some of those parts had to, but at a size like this, it ended up it was kind of a new thing, and I'll explain what I mean by that in a second. So I had to do the VN pad on that, which also made debugging a little hard. Right? Because if you can't get access to the signals that you want, then you're kind of, possibly going to be in trouble. So basically set everything up here so I could at least test capacitive touch, test all the LEDs. And when I first got the board, I powered it up and like it just kept resetting. Raspberry Pi was not booting up, and I'm like, oh crap! Like I don't have time for this. So I ended up hooking up UART to it, watching the boot log, and everything seemed okay. But at the same time as I hooked up the UART, I had been powering it. Originally, I had been powering it by the battery. But then when I was doing my testing with the UART, I was powering it by the regular wall wart, and everything was working fine. But then when I put the battery in, it wasn't working fine. So it turns out I hadn't actually charged the battery. Now I'm like constantly charging the battery just to be safe. Because this thing actually like can draw, when it's playing, it can draw over 1.5 amps. Like it's a freaking boombox, it's pretty loud. And even in idle state, I can't remember what it is. It's like a couple hundred milliamps or something for the Pi to run. So yeah, I was like really nervous about getting this back and having it not work, but then it turns out that it worked, which was very exciting. And played around with the NeoPixels of different colors and stuff, but just to prove, again, everything worked, so I could actually now start focusing on other stuff. Dog was not impressed with the Boombox. It turns out that I guess dogs like can really feel the vibration, so she was not as excited about it as I was, and then like subsequently left the couch after that. But I wanted to test it. As far as the software side, I used a package called Mopidi, and I hope I'm saying that right because we made a video about this, and I also called it Mopidi. A very cool kind of Python-based music server, and there's a bunch of Raspberry Pi-based music options. It just turns out that those the Pimoroni Pirate audio module that I was using in my initial testing also used Mopidi, and it was very modular as far as like, okay, how do I get the capacitive touch buttons to work, to control this? So I could write some extensions and do some stuff. So really, really nice package, and there's no way I would have been able to do any of this stuff without a lot of existing work, right? Because we're kind of all building on other people's stuff. And yes, this is going to be open source as well. So yeah, Raspberry Pi, Mopidi, there's a bunch of different control methods that you can use, and the tool itself can actually do like Spotify playlists and all sorts of internet things. But my goal was just to like get this thing working in playing local music. So I have songs stored locally on the micro SD card, but then you can control it through a web browser, through phone. So all these different extensions that you can use. Really, really neat player. So maybe somebody will like build upon this, or maybe later on when I'm tinkering with it to do more exciting internet things. I also have it restore the state on power up. So it's sort of like if you pause the music and then you turn off the boombox, when you turn it back on, it's going to start playing from that same spot, like you would when you turn off your boombox. Though I don't know why you'd ever want to turn off your boombox. And then this module here is one that I created to kind of combine the Pimoroni module that they were using for their capacitive touch buttons, which was Python-based, to roll into Mopidi. So basically taking like the existing GPIO connection, button connection control of Mopidi, modifying it with this stuff, screwing around with Python a lot, and like it finally worked. I still can't explain why, but it does. And there was basically something with like, I knew what I was doing, but Python, like I write in C in assembly, not Python. So like the whole thing with like self whatever function thing, like it just wasn't doing what I wanted, and I just kept trying different iterations of things, and then it worked. So cool. And then some other modules too. Yeah, so I mentioned the Pimoroni had already the DAC stuff set up. They also had this program that hasn't been supported in a couple of years called PyViewMeter, which would take audio, I think, from the ALSA kind of input and then display it on their own LEDs. So I basically took the NeoPixel LED library and then rolled that in with their stuff to make it work for the NeoPixel LEDs as a VU meter. And again, kind of Linux magic. And I'm glad that most of it worked and it didn't require a lot of debugging, because my debugging was basically like changing code, recompiling it, and then seeing what worked. You have like a couple windows open of your Raspberry Pi and you're just doing that over and over again. And coming from an embedded background where it's like, I want to see every single line of code and how it's changing registers, like this was very disconcerting to me, because, if there's a bug, is it in the userland code? Is it in the driver? Is it in the kernel? Like you don't really know. So yeah, a lot more stuff could have gone wrong, and I'm glad it didn't. As far as making the boombox look cool, because boomboxes have to look cool, and I can't make things look cool, so I reached out to my friend Mar, who has done a bunch of different artwork for lots of events, but probably most notably that some of you may have seen through DEF CON, and very kind of colorful, kind of cyberpunkish looking, but they like to hide lots of elements inside of the art, which I thought was really cool. And it was like, what if we could combine their art with like my circuit board and turn it into something? So yeah, they were willing to get involved, which was very exciting. And we kind of went through the process of the art side of things. And I basically gave them free reign, right? Of like, here, we're making this futuristic looking boombox, but we want to have these retro elements, but it's giant. So how do we fill all of the space? Because all we have on the boombox are the capacitive touch, the VU meter, and some lights for the capacitive touch, and then like a cutout for a tape, which I'll talk about that later. But a lot of empty space. So I was really worried about how to make it not look dumb, but they are an artist and made it not look dumb. So this is kind of the first rough sketch, and we had a couple phone calls of like, yeah, let's see if we can like, change some things around. This was the second draft, where stuff is a little more defined as far as like placement of things and the features that are going to be there. And then here is the final concept art, which I'll show you next. And once we saw this, we're like, okay, are we going to actually be able to make this as a circuit board? And we had basically worked and said, okay, like we know that we can do, multiple solder mask colors. So we basically, told Mar, like, just choose whatever colors you want, see if they can, maybe the fab can custom mix the colors and stuff. And basically came up with this, and then it was our job to now take this, integrate it into Altium Designer, which is what I use for circuit board layout, and then get it into something that could be manufacturable. So this was the goal, and it looked super, super cool. I mean, just seeing that's like, wow, it's awesome. And then the pressure was on, right? Because then I had to go from the green board to something like that, and I didn't have an option of doing multiple runs. Like, it was one or nothing. It was either going to work or not. So luckily, a friend of mine, Mark Hughes, who is in the corner over here taking pictures, likes doing circuit board design consulting stuff, among other things. And he has some connections to a couple different circuit board fabs, most notably Royal Circuits, Advanced Assembly, who I've used for other projects before, and a lot of you probably have used them if you've ever done anything with Oshpark. But I just didn't know enough about the fabrication process of what we were trying to do with this. So Mark was a huge help to make the right connections and get the phone calls together, and many, many phone calls. And I think what's really important is a lot of times we're used to clicking some buttons, uploading some Gerbers or KiCad file and just sending it off and boards magically come back. But there's something really important about like a human connection. And you can do really cool things when you talk to other humans. Hence, Supercon. Because you get motivated and somebody might have an idea and you go, oh, I want to try to use that. So we had a lot of phone calls directly with the fabricator to say, what can we do? Can we have our controlled depth milling? Can we do multiple solder mask layers? Can you match the Pantone colors that the artist gave us? Can you do via in pad on every single pad on the circuit board? Not just the ones I needed for the audio amplifier. Stuff that was just, to me, ridiculous, and they're like, yes, like, let's totally do it. If you design circuit boards, here's a little stack up, and normally we never have to deal with this if you're just doing like a 2-layer board, 4-layer board, but because we had that via in pad, and we wanted to have some thickness to do the controlled depth milling on the front side, we needed to have something that the circuit board fabricator could actually look at and reference as they're building stuff. So this is called an unbalanced stack up. And basically, like, the top side up here is really the back side of the boombox, but we have the copper on the top side, and then our first layer is what's going to be the laser drilled via in pad. So really, really small. I think the minimum size, so 6 mil, 6/1000 of an inch is how small those microvias are drilled laser wise, and we had 232 of those. Which the circuit board fab was like, yeah, fine. Like, if we're gonna do 3, we can do 232. It's just gonna take a lot longer. And but they did it, and it was amazing. So that was to the first layer. Second layer, we used regular, traditional mechanical blind vias, and those were 0.100 of an inch minimum, and 142 of those, because I wanted to bury all of the signals inside, and you'll see what it looks like when I did that. That was also really nerve-wracking because usually, like, you want to have access to your signals so you can mess around with stuff. And but I wanted to see, like, what would the circuit board look like if there were no traces and you would just see the components and nothing else. So going from, like I'd mentioned, using some via in pad before once in a while to like doing it on the whole board was really cool. And then we had basically, like, those were close together, and then we had like a really thick substrate. And this was an 1/8 inch. So the actual main circuit board is an 1/8 of an inch thick. And half of that was kind of bulk substrate so we could make the tape cut out. But on the front side of the boombox, the back side of the board, we needed to have the copper traces for the capacitive touch. And we wanted to use copper on that side for like some artistic elements. So we basically had just gigantic through vias all the way through. Only 6 of those, and those were larger, like 13 mil. All the way through. So the capacitive touch here goes all the way to the other stuff on that side. And this is something I had no idea about. And when I was talking to Mark, he like wrote an email to the fabricator and he's like, we want the unbalanced blah, blah. And like before we even got off the phone, they had made this. And it was like, yeah, okay. And then they just told me what specs I needed that I could put in the tool, right? Minimum via size and all of that. So very exciting. This is completely impossible to see, but trust me, And I guess if you're on the internet, you might be able to see it better. I wasn't sure what color scheme to go with, so I probably shouldn't have chosen black. This is a mechanical drill drawing. So one of the Gerber plots that you'd submit with your circuit board fab, right? You can see it. Yeah, it's on the everyone go to their phone and see it on the live stream. Anyway, the PDF of these slides will also be up. So what I wanted to kind of point out here is that, again, talking to humans and working directly with humans, you can actually write notes on your drill drawing and, oh, that looks a little better, thank you, and specify things. So we had controlled depth routing, right? So if you think about a milling machine, right, if you're like milling something out, you can do that on a circuit board. So this tape slot cutout is a 10 mil depth and then like a 62 mil depths. So the the tape has like the extra little lip at the bottom, so that fits right in. The VU meter and the buttons for the capacitive touch, they don't drill all the way through. So we're using the PC board material to diffuse like we normally do for blinky lights on badges and stuff, but we're basically only milling halfway through the board from the backside, and then the LEDs kind of sit in little pockets. So you can specify that if the circuit board fab has the capability. So I'm just basically specifying the mechanical requirements. And then there was some stuff in there about like, cut out the handhold slot. And then on the backside, I'll show you pictures of later, I built a frame around it just to give it not really mechanical stability, but a way to protect like some of the components. And I put little keyhole slots in there so you can mount it on your wall. So you specify all of those things on here, and then a human on the other side reads that and says, oh, okay, that's what Joe wants to do. And then if they have questions, they can talk to you. So this was like probably, if you're doing complex circuit board fab, like this drill drawing ends up being the most important thing. And you actually can specify things maybe that the circuit board fabricator doesn't necessarily like advertise. It wouldn't be a proper Supercon without showing some like pictures of robots. And so I have a couple pictures. You know, the circuit board fabrication process and assembly process requires many steps. So I just chose a couple screenshots that I thought were worth showing. This is one of the first layer copper. It's actually the bottom layer copper, which is the top of the circuit board, coming out of the developing stage after the dry film was put on. So this is copper before any solder mask or anything like that. And it's wild that a lot of these machines are just like conveyors spraying chemicals and stuff now, where it used to be tanks, and I could be wrong. There's probably still tanks, but the fact that it's, this conveyor process to make these boards is really, really neat. Here's a little sneak peek of like the board coming out of the developing phase for solder mask. And this had to be done 7 times because we had our regular copper, and then the first solder mask coating that went on was clear to keep actually it was plated, so immersion gold, covered over in clear solder mask. And then we had, let me see the order. Then we had a black solder mask, and then we had a white solder mask, and we put the white down so all of the other colored layers on top would sit there and be brighter. So it's like when you're silk screening a t-shirt, right? That same sort of thing. We didn't know if that was gonna work. The circuit board fab thought it would work, but nobody knew, until we tried it, which was exciting. So this was the third step of the white, and then we had green, pink, blue, and yellow, all Pantone colors that they had matched. And I think sometimes too, like when you're specifying non-standard things, people get excited about that at the fab. They're like, oh, let's try this. It's like when you go to a restaurant and you say, oh, have the chef, make me something special. And I think they get excited because they're not making the same thing over and over. I could be wrong, but in my head, that's what, made sense. One other thing when you're making boards, I don't know if every circuit board fab offers it, but you usually want to ask for like 100% electrical testing. So there's these arms with little needles doing continuity testing across your whole net list to make sure that the board is fabbed properly. Because if you can narrow down, if there's problems later on and the board's gonna work, assembly's been verified, like it reduces the number of things you have to debug. So this thing's really cool because it moves around and tests everything, and then at least that your board is fabbed properly. And especially with like the complex, all the via in pad stuff, like you really wanna know. I did have videos of all of these, but I didn't want to bore you with it. It would have taken way too long. Here's like pick and place, coming down, doing traditional type of placement of some of the components. But then it turns out that there was this manual side of things also. And I think because the pick and place maybe isn't set up to drop stuff into little pockets, but here's a great shot where you can actually see the controlled depth milling is halfway through the board. And then somebody during the assembly process, after the solder paste is put on, pick and place is done, and then somebody is manually placing the other parts before it goes into reflow. And then here's the obligatory shot of it coming out of reflow. One other thing that if you can and you're using BGA parts or really small parts is getting some X-ray inspection. Most circuit board fabs are going to offer this. Actually, probably all of them offer it nowadays. And I like to do this, especially with prototypes, but I did it on the production ones also because, again, I wanted to reduce the chance of failure of something going wrong. This let me verify that the micro BGA solder balls were properly aligned on my footprint because I'd never used that footprint before, created it from scratch, added the solder mask definition, and needed to make sure it was aligned properly. So I did this on the prototype, so that would be one less thing to debug, and then did it on the production ones as well just to feel a little bit better. And here you can actually see, for the prototype, these two via-in pads in there. So those are actually like super, super tiny. And then the production version, again, had them on every single ball. But X-ray will give you that kind of nice peace of mind if you're dealing with complex things. And you can even do failure analysis also. So like if your solder ball quality isn't good and you have a failure, you could bring it to an X-ray failure analysis facility, and they can do like a 3D CAT scan and say, oh, that doesn't look like it wetted properly and that it was not stuck on there the way it should be, deformed or whatever. You can do that with components also, if there's cracks in components. So I did mention the tape slot cutout on the front, which basically has nothing to do with electronics. But we thought because it's a boombox, you need to have a cassette tape in some way. So I was like, what could we do with a cassette tape? And what could we do that I know is going to work? Because I wanted to try all sorts of things of like, could I turn the boombox on with a magnetic sensor of the tape? And I wanted to see if I could do it in a way of not having to modify a cassette tape. But that just ended up being way too risky for kind of what our time frame for this, which also ended up being way longer than expected. So I ended up taking stock tapes and adding magnets to them, which is probably the worst thing you want to do with tapes. But I did it anyway, because hacking. And basically I have two different versions. One of them just has two magnets in the tape, so you can use it as like an aesthetic thing of just putting a tape on there, and I'll show you that in a second. And then there's one, you can see that one magnet in the middle. These are like 10 millimeter neodymium magnets from Amazon. And there are mates on the back side. But the center one, there's a reed switch on the back. So if you have one of those, you can put it in, and that will actually turn on the boombox also if you don't want to use like the manual switch. So just to give it some kind of throwback, feel to it. So here's the final board. Thank you. I'm so glad I'm done with this project. So this is the final board. Capacitive touch sensing buttons are actually, part of the graphical elements, and they were really close together too. So I was a little worried that there was going to be some overlap of that sensing, because the data sheet is like, make sure it's X amount, apart. And I was like, YOLO, whatever, I'm going to do it. But I did end up making sure that there was like some solder mask thickness in there, so it actually, stopped some overlap, I think. But yeah, so that ended up working, and then this again are diffused, milled from the backside, so the lights come on when you press the buttons. And then the VU meter, you can't really see during the day, but maybe up on stage you'll see it. And so here's the backside. So this is, battery up at the top, and I'm basically just using the 5 volts from that, so going into like a micro USB connector. Up at the top there is our power, on-off power circuitry, and then the DAC, and then that goes to the individual left and right channels for the audio drivers, and then the capacitive touch stuff is down at the bottom. Another thing that I almost messed up too is I hadn't fully read the data sheet for the cap touch stuff, and it was like, make sure, no signals go under, no copper pores go under, and I had a copper pore across everything, so at the last minute I was able to make like, a copper pore cutout, which I think helped. Oh, another issue too. So with the Raspberry Pis, I didn't want to use like a header or anything like that. I wanted to have it as flat as possible. So I just put some flux down on the immersion gold pads and then like double side taped the Raspberry Pi and then just hand soldered. I had problems with connecting the ground, not surprisingly, because my ground plane on here was huge and the ground plane on the Raspberry Pi. So when I first assembled one of these, it wasn't working, and I'm like, oh no. So I had to go through, debug everything, make sure all the connections. I was like, oh, the ground connection, which if you've seen some of my other videos, ground ends up being like always a problem for me. So yeah, finally used like a much hotter soldering iron tip, got ground connected, and then it turned on, and that was also very exciting. I did mention that we made a video. And really, the video was part of this process, and kind of a lot of it was self-filmed, but then we had an actual professional cameraman friend of mine come and film some of it. But of course, we had to do something for the finale, because seeing me just build this is not that exciting. So we hired a local breakdancing crew in Portland, Oregon named New Birth Crew, and we set up, like, walked past some no trespassing signs to this, like, cool location, and built an actual dance floor, and then these guys came and like danced to the boombox, which is really, really cool. So now we had an excuse to like, kind of mix different genres, like engineering and boomboxing and breakdancing and art and everything. But the video is really funny because you can tell like, they're cool and loose and stuff, and I'm just standing there like nerd with boombox watching them. It was a good contrast, but yeah, really, really fun. So that video is going to come out November 15th, along with like the design files and everything. I just need to get my act together. My friend accidentally wiped my website, so the good old RM-RF mistake, and killed the whole thing. So that's kind of broken. I got to get the website kind of fixed up again so I can actually host all the files. And I host them locally, not on GitHub, because it's just easier. But yeah, all that stuff will be up November 15th. So definitely watch that. And yeah, let's do a little demo and we'll see how well it works up here. Actually, I'm going to put this down. Can I fit it back in? I'm probably doing it totally the wrong way. I'm just going to put it down on the floor. or to somebody who knows what they're doing can stick it back in this. This is always a problem for me. Mic drop. Yeah. Okay, Mark will hold it. Thanks. Actually, here, I'll talk while it's... Okay, so I just powered it on, but because it's a Raspberry Pi, it takes like 30 seconds to boot. So normally you would do this before you like roll up to your, people on the street or something. I probably should have turned it on before, but I want to make sure the battery doesn't die. So it's going to automatically start playing. And Mark, I'll need you in a second also, but let's see what happens. Can everyone see it? Okay. Okay, hold on. Here, hold this. Okay, so this is so confusing. So I just stopped it because it was like playing from before. So now I'll restart it, and then Mark can hold the mic up to the Piezo speaker elements, and we'll see what happens. And you should recognize this song too. We actually not only had artwork from somebody in the hacker community, we had an artist, musical artist from someone in the hacker community as well. So dual core, all the things. We got to license their song and use it in the video, which is really cool. So here we go.
With a Commodore 64 can hack into NASA.
Oh, and then, of course, this part. So the boombox is already on, but this is like the decorative element if you don't believe me that it works, right? So, yay. Oh, there are other songs too, right? So you can have a whole playlist on here. So we have like a second song, and you can change the volume and yeah, and stop it and everything. So there, now you have your world's thinnest boombox. Okay, So I do want to thank some people. Of course, you know, like no project exists in a vacuum anymore, at least. None of this stuff would have been possible. No project really in the past probably 5 or 10 years could be possible without the help of other people. But yeah, TDK, of course, for letting me use their parts, and Mar for the art, and Mark Hughes for circuit board stuff, New Birth Crew, Dual Core for music, Summit Interconnect to do the circuit board fab and assembly, and then my friends Fred and Freddie, who filmed the video and then edited the video and all of that. So just a lot of, you know, really cool people working together, which was very exciting. And then some other, you know, resources, references to some of the photos and tools that I used in the presentation. And yes, thank you for coming. Thank you for listening. That is a real mustache, by the way. And yeah, so hopefully you know, learn something new, some new technique you can use, or get some inspiration for a future badge or future project. And yeah, enjoy the rest of Supercon. And if you have questions, I will be walking around with the Boombox. So thanks again.